Okay, so this is just a quick reflection of the laboratory on Monday the 21st of November 2016, which was the sulphonamide practical. So this was the practical you set, the benzylamine, sulphonyl chloride, sodium hydroxide and water. So I made the comment in the lab of writing a lab book up. So this of course isn't a lab book, but how to write up this, a schematic of the reaction, molecular formulas, molecular weights underneath, materials, relative molecular masses. Masses of material are down in this kind of column, skewed out. So what I have wrote on this side is a density. So the two reagents were liquid, so once we find the density and the volumes are given, we can find the masses are shown. This allows us to calculate the number of moles, as shown here, and then equivalence. And with that in mind, we write up, obviously, in this third person past tense idea, as we see here. A percentage yield is a calculation you have to do. So you find out the limiting reagent of, here is benzylamine, so the benzylamine is a limiting reagent in mole quantity times the molecular weight of the product. Here gives us an approximate mass that we should aim for. Of course, if you were to change your values of 1.1 mil, 1.2 mil, your mole value here would change. That would change, hence the yield or theoretical mass would change. Your yield then is your actual mass divided by your theoretical mass as a percentage. So once you go through your exercise and collect your crystals, white crystals produced after recrystallization, your mass goes in there, your percentage yield, your melting point reference, you recorded your infrared, and then you have to write in as well. I'm not doing this because it's for you to be assessed on this. Your NMR data down here at the bottom, so your NMR data would then fill in here. So we would have a proton NMR with 400 megahertz, and the solvent would be CdCl3, and you would assess and assign your NMR in that manner. Just some comments about the practical nature of this work. I noted that a lot of students walking around the lab, and I did mention this to some of you, were not in the mood to clamp your very delicate pH electrode into position. So once we had a flask, that is a flask by the way, on the hot plate stirrer, the flask then should be clamped into position. So it should be clamped with the boss onto the stand, and then the stand, of course, the hot plate stirrer should sit onto the stand, right in that manner. So you have a clamped flask here, clamping on the neck, and your electrode should be placed into the stirred solution. This is the electrode, the wire, and that should be clamped at that position. So when you had your magnetic flea in position, which I'll show here, the magnetic flea does not want to be contacting the electrode and causing it damage. So you clamp the electrode above the level of spin of the flea in position, so the bottom of the electrode is being submerged by the water, the benzylamine, the sulphonyl chloride. Some of you commented that the pH was dropping over time. Well, that's the case. What's the byproducts of this reaction? Well, sodium hydroxide, benzylamine, HCl. One of the byproducts of this reaction should be the generation possibly of HCl. Some of the benzyl chloride being hydrolyzed, so HCl maybe should be generated in situ here. That should see a drop of pH. So that was something to comment on. Recrystallization from ethanol, I think most of you did pretty well, and obviously when you were extracting this at this point, extraction with DCM, so if this was our separating funnel at this point, if you had an aqueous layer and put DCM in, your aqueous layer then would be the top layer the DCM layer is the bottom organic layer, so the sulphonamide is present in the bottom DCM layer. Okay, so those are my reflections of the laboratory, and it's up to you now to write this up and to present as appropriate to any of the academic staff members who are in the lab with you, and we can give you some comments and feedback as appropriate. Okay, thank you.